Any doubt up to these 3 points? Any doubts? Is it clear?
No doubt, sir.
Is it clear to everyone?
Yes, sir.
Yes,
Oh,
sir.
Yes,
okay.
sir.
Yes, sir.
Okay, good, good. Thank you for your response. Okay. Now, so why he proposed these things? Before that, Wiens and religion could not explain the black body radiation problem, and he come up with 3 different postulates. Okay. After this one, he proposed able to derive the expression and able to explain the complete derivation. Okay. Now we will see how he derived. Okay. Now, sorry, 1 second, please. Just a second. You can see PPT, right?
Yes.
Just a minute, I will share it again. Okay, now it's sorry for the interruption. Okay, now after that, just before, what is the Maxwell-Boltzmann distribution? Maxwell, you can say this Maxwell-Boltzmann distribution. Anyone, please? Suppose you have number of atoms here, number of energy levels. Suppose here ground state, this is ground state, this is E0, and this is the suppose E1 or maybe En or E2. Suppose number of particles here 1 and number of particles here 0. So or you can say this is E2 level, this is E2, number of particles here n is equal to. So what is the Maxwell Boltzmann distribution? Anyone, please? I think Maxwell Boltzmann distribution. Distribution are what this will explain? Maxwell or Fermi Dirac. What this explain generally? What these laws explain? So if you don't know, okay, these laws mainly explain how the atoms are distributed among the energy levels, among the different energy levels. Okay, Maxwell, Boltzmann, or Fermi Dirac, and uh, one more law is there. Forgot. Okay, so here, what is the Maxwell distribution law here? Suppose n is equals, first you write the number of atoms in a excited state 1. Suppose n1 is equal uh, and suppose there is a you write here, suppose maybe you write this one, suppose here instead of 1 we'll take a, here n0 particles are there, here n1 and here n2 particles are there, or maybe atoms are there. Okay, this is ground state. Suppose you are writing number of particles or number of atoms in the ground state, n0 is equal to what you can write here, number of atoms are, you can write n0 and exponential minus what is the energy of ground state, E0 by kt, right? E0 by kt. Suppose if you want to write E1 state, that is number of particles, total number of particles n1, and this is the n1 number of particles small n1, E1 by kt. Like that you can write total n number of atoms, right? N number of atoms. Suppose here we have n number of atoms, nn. You can write this is capital N means total number of oscillators. Here each atom, what we consider, each atom is oscillator, right? Each atom is oscillator. Okay. Like that we have taken total number of oscillator and e to the power of what is the nth state energy, En by kt. En by kt, right? En by kt. This is the Boltzmann expression for nth state. Boltzmann expression for nth state. Okay. From this expression, we got the number of oscillator. How many oscillators present in a system? We got the expression. Okay. If you take any system, we got the expression for number of oscillators are number of atoms present in a system. That is we got. Okay, that is capital here n, capital N is equal capital N number of oscillator minus e to the power of En by kt, En by kt. Okay, this is expression 1. Okay, this is expression 1. Okay, now we want the average energy. Okay, we want the average energy. Okay, first one, what is our main aim? So main aim is to estimate the radiation. Our aim is what? First, using black body radiation, what we are going to estimate? Radiation. First we should know aim, and after that you should think how you will reach the aim, how you will solve the aim, which way if you go, how you can reach the aim. That is the approaching the problem. Okay, radiation of black body, okay, we are going to estimate this one. So that radiation of the black body, emitted radiation from the black body, E of nu and F nu d nu is equal to the this average energy into number of oscillators in a state, number of oscillators in a state, in a system or in a black body, whatever you can say. Okay, this is we are going to estimate. First you estimate the number of average energy. After that, average number of particles, how many particles are there in a system, you have to estimate these two. Estimate, after that you can multiply it, you will get the total emitted radiation from the black body. First we will try to estimate the average energy. Okay, we will try to estimate the average energy. Okay, that is equal to the average energy is equal to what we are doing, average energy of a oscillator, of an oscillator, or you can say whatever. Okay, average energy of a oscillator, suppose that is equal to En and Nn by summation over n, or you can write average of energy into number of atoms and by, suppose how you will take the average. Suppose if you have suppose you have one student in a class, he got 50 marks. What is the average? 50 only, right? 50 by 1, right? Suppose there is a two student, one got 50, one got 30. What is the average in a class?
40.
Yes,
40, sir.
yes. Yeah, one student got 50 marks, second student got 30 marks. Okay. So how you will do average? Sum of these marks and 30, 50 plus 80 by total number of students. Two students are there. So you got average 40. So here also total energy and number of atoms or number of oscillators in a system, that you have to divide. Okay, that is why we are dividing here. Okay, now we will rewrite this expression. If I take this, if I remove this average, how can I write? I can write summation. This is this one, n is equal to 0 to infinity. We don't know how many atoms are there. That's why we are taking 0 atoms to infinity atoms. Okay, that is En and Nn. Okay, En and N. Next one, here also you can write summation over n is equal to 0 to infinity Nn. Okay, this is the average value. If you derive this, if you solve this one, we will get the average energy of a oscillator. We will get. Okay, now we know En value, we know, right? Nn also we know. What is the Nn En value? En is called what? En. What is the value of En? Just go to the starting points. You will get the answer. Just while explaining Planck's blackbody radiation or Planck's postulates. That is what I have said. Whatever emitted radiation from the black body in integral multiples of what? Integral multiples of what? Yeah,
H
that's
nu.
yes, that's good. So you forgot just before we have discussed. Huh? Or you are thinking maybe this energy is something value, not this value, right? You're thinking that is right. That's why you are not answering. Okay, En is equal, suppose nth state and h nu. Whatever emitted radiation from the black body is quantized and discrete. That is integral multiples of h nu. That is the very important postulate from the Planck's law. Very important this one. Okay. Second one already we have derived. We have got this expression. Capital Nn is equal to n into exponential En by kT, right? En by kT. This is we got from the Maxwell-Boltzmann distribution. We have two things. Just you substitute there. Just you will get the answer. Okay. Why we taken here summation n is equal 0 to infinity? We have to sum up. Suppose in class 2, suppose you have class. In the class you have two students. How you will take average? You have to add first student marks and second student mark. Or you can say in class you have 60 students. How you will take average? You have to add 60 students marks and you have to divide 60 number, because number of students 60 and 60 students mark. First you have to sum up and divide with 60 number, then you will get the average. Here also same thing. Here we have considering we don't know how many atoms are there, that's why we are taking n is called 0 to infinity. Okay, we are summing up all atoms. Okay, all oscillators. Okay, oscillators of energy of oscillator. Okay, now just I am writing again, n is called 0 to infinity. En is called what? Nh nu, right? Nh nu. And nn is called what? Capital N into e to the power of En by kt. En by kt. And in the denominator also same thing. Summation over n is called 0 to infinity capital N e to the power of minus En by kt, right? En by kt. Now here this n and this n is same, right? You can cancel out this both ends. Okay, this is capital N, this is capital N. So next thing, summation over n is called 0 to infinity n h nu exponential. Here also En means what? You can write same thing, n h nu by kt, n h nu by kt. Okay, now in the denominator also you write the expression. Here also you write the summation over n is equal to 0 to infinity. Here this term is not there, only number of particles, that is En means what? Nh nu, right? Nh nu by kt, Nh nu by kt. Now we got this expression, right? Average energy is equal. Now how you will solve this one? Now what is our job? What is our job? You have to substitute this n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, like that you have to add. Just what we have done, just from the postulate 1, En is equal to nh we have taken. After that Boltzmann statistics we have taken total number of atoms or total number of oscillators, and we simply substitute in the average energy formula. Okay, average energy formula. From there you have to substitute n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, like that. Suppose n is equal to 0, what is the value? In the here, what is the value if you substitute n is equal to 0?
0.
Zero.
Yes, 0. And next n is equal to 1, what is the value? H nu into e to the power of minus h
H
nu,
nu into e power
H
minus
h
K.
nu by
h
kt.
nu by kt by
Next 2h nu by 2h nu into e to the power of h nu by kt, right? Sorry, 2h nu, right? So
Minus
like
2.
that, minus 2h, like that it will continue. It will continue infinity, up to infinity, right? Up to infinity. In the denominator also same thing. If you n is equal to 0, if you substitute, what is the value? If you substitute n is equal to 0, what is the value here?
1.
Yes, good.
E power
1.
minus h by k.
1. 1. E to the power of 0 means e to the power
1.
of 0 means 1. Okay. And e to the power of h nu by kt and e to the power of minus 2 h nu by kt. Okay, like that this will also continue, right? Up to infinity. Please mute, someone is muting. Please mute. Okay, thank you. Okay, this series will continue up to infinity. Okay, up to infinity. Now how someone is please mute. If you have doubt you can ask, otherwise please mute. So this series is continuing. I will take the next page. Okay. So here what we will do, how we will simplify this expression, just think of this expression. So we will consider e to the power of h nu by kt equal to some x. Okay, we will simplify this expression. Otherwise, it is a lengthy infinite expression. That is very lengthy expression. We will simplify. Average energy is equal. Now, first expression, what we have h nu into what is that? You substitute e to the power of minus h nu by kt equal to x. Just you substitute x. What you will get here? X, right? X. After that, 2h nu into x square. After that, 3h nu into x cube. Okay, this is simple expression. Just you have to substitute. Okay, nothing worry. Okay. Here also, after that, simply you substitute x and x square like that. It will continue. Okay, this expression will continue. Okay, now you know some formula for this expression. Just you take out h nu x common out from this expression. What you will get here? 1 plus x plus x is x square, right? Like this, right? Okay, sorry, here you will get the 2, right? 2 and 3. 2 and 3. Yes, yes. Okay, here same thing you will get. Okay, now you know expression for these formulas. You have a series, infinite series. What is the how you shortcut you can write? What is the series of this one? Anyone, do you remember this one? Do you have any idea? In the first semester, did you get these formulas? 1 minus x to the power of minus 1. What is the answer? 1 minus x to the power of minus 2. What is the answer? Okay, this is simple. I think you got it, but you have gone through this expression, but I don't know you remember or not. Okay, 1 minus x to the power of minus 1 is equal to 1 plus x square, this series. And this one is 1 plus 2x plus 3x square like that. Okay, these are the two infinity series. You might have known, but you forgot maybe. Okay,
Yes, sir.
just you recall it. Okay, just you recall them and you will
Yes,
remember.
sir.
Okay. Okay, here what we can write? 1 minus x to the power of minus 2, and here 1 minus x to the power of minus 1. Okay, here you can cancel out, right? 1 by 1, here 1 and here 1 also you will cancel out. Then you will get h nu x into 1 minus x to the power of minus 1, right? How you can write this one? H nu x by 1 minus x. Can we
1
write like
minus
this?
x.
Can we write like
Yes,
this?
sir.
Yes, yes, good.
Yes,
Okay,
sir.
yes. After that, you divide with x. Okay, you divide with x. Then you will get 1 by x into minus 1, right? Just I am dividing here and here, you can divide downside also. It's a your wish, or however you can do. Okay, now average energy, we got this expression. Now what we have done is just we have simplified the expression. Nothing we have done, just simplified. Now average energy is equal to h nu. You keep it as it is. What we know, 1 by x is equal to what we consider e to the power of minus h nu by kt is equal to what we taken x, right? Isn't it?
Yes, sir.
Yes, sir.
Now 1 by x is equal to what is the value now? 1 by x is equal, just we want
Yes.
h nu by kt, right? Just this will cancel. Now just you substitute there. Just you substitute. Our job is to just substitute h nu by kt minus 1. Okay. Just we have substituted 1 by x. Just to simplify the expression, we have considered h nu by kt is equal to x, and after simplification again we substituted x value. That's it. We are doing very simple calculation. We are simplifying the problem. First, for simplifying, we have taken e to the power of minus h nu by kt is equal to x. After simplifying, we are resubmitted that x value. Okay, that is we got E value. But average energy, we have to know number of particles also, right? Number of oscillators in the frequency range nu to nu plus delta nu. So this Planck's law is a function of frequency or wavelength, but we don't know number of oscillators within the range of nu to nu plus delta nu. So that means what? Nu plus delta nu means what? Suppose frequency 30 Hz to maybe 50 hertz, like that. There is a particular range we are taking the number of oscillators. What we are taking? Second one is number of, we want only EM spectrum, right? We don't want total, we don't want unnecessary infinity. We don't want infinity up to infinity, but we want only up to energy EM spectrum only we want. Up to infinity we don't want. Okay, number of particles up to infinity we don't want. Okay, but only number of oscillators within the range of nu to nu plus delta nu. That is complete EM spectrum we want. EM spectrum we want. Okay, for that we are considering a particular wavelength range or particular frequency range. Okay, we don't know number of oscillators within this particular range. That's why we are going to write the expression for number of oscillator within the frequency range within the EM spectrum, or you can say within the EM spectrum. That I will write the direct expression. If I get already today is we are dealing with more derivations. Once you get, I will explain this expression also. You can write number of oscillators within the range of frequency, that is nu to nu plus delta nu or d nu, whatever, 8 pi nu square by c cube into d nu. This is the expression 2. So do you have any doubt how you got this expression? I will explain in the next class, because already today we are deriving lots of these formulas. Okay. So first expression we got average energy and number of oscillators within the frequency range we got, right? These two expressions we got. Now what we want, what is our aim? Next one, what is our aim? What is our aim? What we are going to solve actually? What we are going to solve? Hello?
Yes, sir.
What we are going to solve actually? What is our aim? What is the Planck radiation law means? What is going to derive? So already I explained. Okay, no problem if you don't know. This using this Planck's law is what is doing? Is doing. Suppose this is the black body. We are heating the black body. We are giving the some temperature to this black body. This black body emitting the radiation, right? What is this radiation? How much radiation is coming? How this radiation, emitted radiation, is depending, how it is depending on temperature, how it is depending on frequency, wavelength. That is we are going to determine. How much range we are going to determine within the EM spectrum. EM spectrum. That's why we have taken only nu to nu plus d nu. Only particular range only we have considered number of oscillators. Okay. Now you want to energy density from the black body radiation. This E nu d nu. That is energy density, or you can write energy density, or you can write radiation from the black body, or you can write radiation density. What you will write? Radiation density from the black body. Radiation density from the black body, or radiation emitted radiation density also you can write. I will write again. So what we are going to do, emitted radiation density. Radiation density, emitted radiation density from the black body, from the black body. Okay, that is what our aim is. So from there, just you rewrite this expression: E of d nu d nu. E of nu means what? Emitted radiation is function of frequency. Function of frequency. Okay. Now just you multiply 1 and 2 expression. 1 and 2. That is what? First expression, average energy and number of particles, right? What is the average energy? What is the average energy? Here. What is the average energy?
H
Hello?
mu by
H
Uh,
nu by
e to the power
e
of
power
e to
nu
the
by
power
kt
of
h mu
h nu
by
by
minus 1.
kt
E
minus
over
1.
K.
Yes, this one. And second one, number of oscillators within the frequency range. That is capital N, right? What is the value? 8 pi nu square by
C
C
cube
cube into d nu.
D nu.
So now our job is completed. Okay, our job is completed. Okay, now just you rewrite this expression. So 8 pi, here one nu is there, here nu cube is there, nu square is there. Total nu cube 8 pi h nu cube by here c cube into what is the value 1 by e to the power of h nu by kt minus 1 into d nu. What is this one? E of nu into d nu. Okay, this is the expression for Planck's radiation law. This is the expression for Planck's radiation law. Okay, you got it right. So this is the expression for energy density, emitted radiation density from the black body per a per frequency range, particular frequency range. Okay, particular frequency range or particular frequency, or you can write if you only write, you want to write only function of frequency, or you can write 8 pi h nu cube by c cube 1 by e to the power of h nu by kt minus 1. This is the expression for energy density from the black body. Okay, this expression is energy density from the black body per unit volume of frequency, or you can write this expression simply in terms of frequency, or you can convert this expression in terms of lambda also. Lambda also you can convert, that we will see. So our job is completed. Now what we have done, so this law, whatever a derived expression, this law able to explain completely black body radiation problem. So earlier Wien's law explained only UV region and religion explained only IR region. But this Planck's law, what they done, they can they expand complete the EM spectra, that is UV region to complete IR region. So with wavelength as a function of wavelength, as a function of frequency, how the emitted radiation is changing, as a function of frequency or wavelength, whatever frequency, as a function of frequency, wavelength, and a temperature. If you change the temperature, okay, what this Planck's law explaining means, if you change the temperature for a black body, how the radiation from the black body, how the emitted radiation. So here black body is there, you are giving temperature to the black body. If you change the temperature, here some radiation is coming out from the black body, right? Radiation is coming out from the black body. How this radiation is changing as a function of wavelength, and or you can say frequency. If you change the frequency, or how the this radiation is changing throughout the EM spectrum, that is he explained completely using this expression. He completely explained how the radiation is depending on frequency or wavelength or temperature, and how the curve is changing, how the spectrum is coming. He completely explained throughout the EM